Hello guys, and welcome to lesson number 3. So in the previous lesson we created our VDB from particles and VDB smooth, and we created the velocities to drive the VDB particles with the velocity trail. And now we will start to get a measure in here. So let's call that here, let's just rename that. I will call it to out maybe base shape. The base shape, and with the base shape we can now further proceed. Cool. Out base shape. We will start with a measure, and with the measure sub we can basically measure our geometry. And let's hit here show handle, and now we can see that will see something because we're currently measuring the area. But what I want to do, I will measure the curvature, and I will do it not on primitives, I will do it on points. So I will go here on points, and I will, I think it needs to update here the measure node with a heavy geometry input. It's not extremely slow, but it will get slowed down. I will choose the width. I will choose ×1, and I will enter maybe, I think 0.1 will do the job. Yeah. Maybe 0.3. Again, it's up to you, but I will stay with 0.2. And what I will do, I will rename that to scatter underscore density, and I will bake the visualized range into the output. So just enable that, and now we baked our attributes basically into our geometry. And what we can use now, of course we can use a VOP to manipulate it further. So when we now press onto our visualize, and we will get up the scatter density, you can see our attribute basically. But I want to manipulate it a little bit further, so bind, we will just bind it in, and we will use the scatter underscore density. And of course you can, for example, pipe that float value out to the color to get a black and white distribution or visualization. But what I want to do, I want to basically remap the values a little bit. So just get a ramp parameter, get it in spline, and I will pipe that out, bind export to just basically, let's get density. So scatter density, pipe it into ramp so we can remap it or re-ramp it, and then pipe it back out to density. And let me just look up. Okay. Get the density as a visualization density, and now we can remap that, for example. And what we need to do, we need to remap the range, so from 0 to 1, I think that should work, yes. And now you can influence basically, or we can influence our final output of the attribute. So I will get that here a little bit higher. And get that a little bit back here. Okay. Cool, so we did that, and now we will blur the whole attribute. So attribute blur, and we will not blur the position, we will blur the density. So just type in density, and let's enable the display flag, and you can already see it's a little bit blurred, but I will bump that up to maybe 4, or let's just use 7. No, let's use 6. That's good. And now you can see that we basically remapped and blurred our values. Cool, looks pretty good. After that, we will get a normal down to get good normals. But I think later, in the end, we will place like an overall unified normal node. And then let's look at the size. Okay, that's pretty big. I want a normalized size for later, so I will just place down a match size and get on scale to fit and uniform scale. And we will then just uniformly scale our whole geometry down. And we can place a null here. And call this out base. Oh, here's already out base shape. Okay, that's not. Then out base final. The final word. Cool. So we did that, and after that we can start to create our maybe scatter ramp. And with the scatter ramp, what I want to achieve is like a random distribution on points based by a noise. So we can distribute some points over here. Oh, I love that. Some points over here over our geometry. We will need an attribute WOP. So attribute WOP, let's place that down. And we can dive inside here. Let me just get my headset down here. Okay. We can dive inside there, and what we will basically do, we'll build up a noise that distribute or will control our scatter density. We'll place an anti-alias noise for that. Pipe the position in, and the noise I will fit that. So basically, I say that all the time, but basically the anti-alias noise, when you look it up in the Houdini help context or menu, you will see that the default output range of noise is -0.5 to 0.5, and I will remap that. So I will go from source min -0.5 to 0.5. And after that, again, a ramp parameter, so we can control our distribution of the noise with a ramp. And I will create a bind node to then export an attribute out. I will call that scatter. With the scatter attribute, we can then manipulate or distribute our points with the scatter node, so we can control the density of the scatter with our noise. For example, we can pipe that out for color, or let's just dive up. Enable the scatter and the scatter here. And of course you will see nothing because we don't got any ramping here, but when we will start ramping or remap our values, we can see we can create our ramp here. And I will move that a little bit to the back. And I want a little bit like of a more soft fall off. So what I will do, I will drag that down here, and I will enable one point here. And now we can enable the B-spline to get it a little bit softer. Of course, maybe you want this kind of big distribution, I want a smaller distribution. I will place down a constant, pipe it into the frequency. And for example, maybe 15 should be good. Yeah, that looks good. And now when we place down the scatter, so let's call this scatter density. So this is our scatter density, and when we place a scatter down here, place down a scatter, of course we will scatter on the whole geometry, but I will just use the density here. And now you can see when we place more points, you will see that we will just create points and distributed areas here, basically created by the noise. Cool. Minus 0.5 should do the job. Should do the job. Yeah, okay. Good. So we did that. And after that, let me look up here. Okay. I will use maybe 500 points, that should be fine. So we will just randomly, or based on a noise, we will distribute 500 points on our base geometry. After that, we can do a p-scale. So what I want, I do it with wax now. So let's create a different p-scale on each little point. So I will just create p-scale, and we will use a little bit of wax for that. So we will get a float parameter and call it rand equals rand open brackets at ptnum plus 1 times channel float. This will be our seed for the random. And now we already got a random value between 0 and 1. So basically the random function in vex will put out or create a random number between 0 and 1 from a seed. The ptnum is basically our seed plus 1. So we will get rid of the point number 0, so we will just add 1 to that, so to get a seed from that point. Also because 0 multiplied by anything is still 0, and we created here a float value. So the rand, we can visualize that f at rand equals rand, just to show you that. Rand. This is now our random value. Click on the create spare parameters to create our slider, and you can see. Let's press the D key on visualize on the geometry tab. You can make the points a little bit bigger, and now you can see we've got our different values here. And when you go to the geometry spreadsheet and hide all attributes, view the rand attribute, you can also see that we created with this little vex function basically a random value on each point. I will get it back to 3, and what we can do now, I want to fit that. So I want to fit the random value between a given value, and we can do that with just fit function. So the rand will equal to a fit 0, 1. Fit 0, 1 because we already have a range of 0 to 1. And what I want to fit the rand, of course, between two channels. Channel float min, and another channel float max. Let's call it max. press Control Enter and get the both values here, and now you can see that we can fit our values between those two sliders. And when we now create a copy to points for a little example here and scatter a sphere onto there, I will just scale down the uniformal scale for now, and we will fit the rand, so basically this value will fit into the attribute called p-scale. We'll get a random distribution. But if we want to control currently the uniform scale, we need to control our geometry, and I don't want that. So what we can do, we can multiply the rand by a final overall multiplier. So channel float, I basically call this mult underscore over for overall. Create that slider, and now we can scale up and down our geometry with a global multiplier distribution. So that is our scatter here, and I will just place down a null again and call this out scatter, and we can use that later to create our scatter geometry on top of the initial geometry. So I will see you in the next lesson.